Planck black holes. A microscopic flash of utter darkness, smaller than a single atom, popping into existence and instantly vanishing. To understand the lifespan of a Planck black hole, you must look at extreme time scales. The common mayfly lives for just 24 hours. A Planck black hole makes the mayfly look like it has been alive since the age of the dinosaurs. These quantum voids last for a fraction of a second so small, it is measured as 10 to the power of -43. If a lamp turns on across the room, before the very first photon of light physically reaches your pupil, trillions of these quantum black holes could have spontaneously formed and evaporated in the empty space between you and the bulb. It vanishes almost instantly. But the next object on this list is not harmless, and if it drifted through our solar system, we wouldn't even see it coming. 2 primordial black holes. An invisible sphere floating in space, perfectly bending the light of background stars around it like a thick glass lens. These anomalies were forged in the crushing pressure of the Big Bang, and their mass-to-size ratio is utterly terrifying. Imagine a physical object exactly the size of a single hydrogen atom. Now, imagine packing the entire physical weight of Mount Everest into that microscopic dot. If someone placed a primordial black hole on your kitchen table, it would not sit there. Its extreme density would cause it to instantly punch a microscopic tunnel straight through the table, the floorboards, and the Earth's crust, plummeting directly to the molten core of our planet. These ancient remnants are tiny and deadly. But the next anomaly on our list doesn't require dead stars or the Big Bang to form. It is forged out of pure blinding brilliance. Kugelblitz black hole. Millions of blistering laser beams converging into a single, localized point of blinding white light, suddenly snapping into a sphere of absolute freezing darkness. A Kugelblitz is a black hole formed not by matter, but by pure radiation. A nuclear bomb generates temperatures of 100 million degrees, creating a fireball of physical destruction. A Kugelblitz requires a concentration of heat so extreme that if you gathered the energy output of every single star in the Milky Way galaxy and forced it into a space the size of a glass marble, the sheer density of the light itself would collapse its own gravity. The light becomes so heavily concentrated it physically traps itself. This sphere of trapped light is entirely theoretical. But the next black hole is very real, and it is the smallest physical void ever discovered by human telescopes. The mass gap black hole. A perfectly spherical, pitch-black void roughly 15 miles across, sitting completely unmoving in the vacuum of empty space. This is the absolute physical minimum size a dead star can be before it turns into a black hole. It sits on the razor's edge of physics. Imagine a compressed ball of iron exactly the size of Manhattan. This is a neutron star. Now add the exact weight of a single snowflake to its surface. That one snowflake tips the gravitational scales, causing the entire Manhattan-sized structure to violently cave in on itself in a fraction of a second, crushing down into a point of zero physical volume. This is the absolute borderline of gravitational collapse. But when much heavier stars die, they create something far larger and significantly more violent. Stellar mass black hole. A rapidly spinning sphere of darkness, roughly 40 miles wide, surrounded by a faint, ghostly red ring of stretched background starlight. Born from the corpse of a massive star, its gravity is a physical weapon. If you stood on the surface of Earth, you feel 1 g of force. If you hovered near the edge of a stellar mass black hole, the gravity pulling at your feet would be hundreds of millions of times stronger than the gravity pulling at your head. You would be physically stretched out into a single, microscopic stream of glowing atoms, exactly like a hot strand of mozzarella cheese being pulled rapidly away from a pizza. Left alone, these stellar graves are completely silent in the dark, but when they have a neighbor to feed on, they ignite into one of the most violent light shows in the cosmos. X-ray binary black hole. A black sphere violently ripping a physical stream of blue-hot plasma from the surface of a massive neighboring star. The ripped gas spirals down toward the void like water swirling down a drain, forming a blindingly bright spinning disk of fire. The gas in this accretion disk is whipping around the black hole at 50% the speed of light. That is fast enough to travel from New York to Tokyo in 0.03 seconds. The sheer kinetic friction violently heats the gas to 100 million degrees, blasting out invisible X-ray beams so intense they would instantly strip the flesh from your bones from a million miles away. At least these binary systems are easy to spot. The next black hole behaves like a silent predator, and there are millions of them creeping unseen through our very own galaxy. Even rogue black hole. A sphere of total, unblemished darkness moving rapidly against a backdrop of stars. The only way you can physically see it is when a background star's light suddenly warps and stretches into a perfect glowing halo around the void, then snaps back to normal as the object passes. A rogue black hole moves through open space at 3 million miles per hour. That is faster than the human nervous system can physically send a pain signal from your hand to your brain. It is a dead star that was violently kicked out of its original orbit by a supernova. now drifting endlessly through interstellar space like a silent, unguided torpedo. These wandering ghosts are terrifying, but their mass is relatively small. To find the next class of black hole, we have to look for the missing link of the universe. Intermediate mass black hole. A dark void the exact size of the planet Jupiter, buried deeply in the very center of a tightly packed cluster of ancient, glowing red stars. A stellar mass black hole weighs 10 times our sun. A supermassive one weighs millions. This intermediate void is the missing stepping stone, weighing exactly 50,000 suns. If our sun were a single grain of sand, this black hole would be a dense bowling ball of pure mass, violently yanking entire stars into its orbit and shredding them into glowing, superheated ribbons of plasma. It is a heavy, sluggish eater, consuming stars one by one to slowly grow its mass over billions of years. This missing link proves exactly how black holes grow over time. But when these dense objects start spinning at their maximum speed, they transform from simple vacuums into cosmic cannons. Microquasars. A tiny black hole with a tightly spinning accretion disk, violently firing two physical, laser-straight columns of white-hot plasma out of its north and south poles. Imagine taking the crushing water pressure at the very bottom of the Mariana Trench and multiplying it by 1,000,000,000. The twisting magnetic fields around this black hole create that exact physical pressure, snapping and acting like a cosmic rifle barrel. The plasma jets are shot out into space at 99.9% the speed of light, plowing through the vacuum of deep space and physically burning through any gas clouds or matter standing in their way. These microscopic cannons are incredibly destructive, but they are just practice runs for the universe. The true monsters anchor entire galaxies, and their physical size completely defies basic human comprehension. 10. Supermassive black hole. A colossal, slowly spinning sphere of absolute blackness, larger than our entire solar system, permanently surrounded by a thick, glowing orange donut of superheated gas. The sheer scale of this object breaks human intuition. The fastest commercial jet flying at top speed would take over 4,000 years just to fly from one side of this black hole's event horizon to the other. The supermassive black hole at the center of our Milky Way contains the physical mass of 4 million suns. It acts as a gravitational anchor so impossibly heavy that 200 billion stars, including our own, are trapped in an endless carousel ride around it. Our supermassive black hole is currently starving and asleep, but when one of these sleeping giants begins to actively feed on fresh gas, it creates a cosmic furnace that outshines the rest of the universe. Quasar. A blinding, violently strobing core of white and blue light. The center is so fiercely bright it completely hides the galaxy of stars surrounding it, exactly like a stadium spotlight pointed directly into a camera lens. A quasar consumes gas, dust, and whole stars at a terrifying rate of 1 Earth mass every single second. If you could capture the exact energy output of a quasar for just 1 second, it would provide enough electricity to power human civilization for the next 100 billion years. The extreme friction of the gas being swallowed generates a physical temperature of trillions of degrees, illuminating the darkest corners of the early universe. Quasars project this blinding light in all directions, but if one of their magnetic plasma jets happens to be pointed straight at you, the consequences are instantly apocalyptic. If you've made it this far into the universe's most extreme environments, drop a like and subscribe, because the next object on this list is capable of wiping out life on Earth without a single second of warning. Blazar. A direct, blinding beam of high-energy gamma rays and superheated plasma screaming directly at the viewer, physically distorting the space around it like heat waves rising off hot asphalt. Imagine someone firing a flashlight at you from across a dark field. Now imagine that flashlight is an exploding supernova, and the beam is a tightly focused laser of lethal radiation traveling for 3 billion years without losing its shape. A blazar is just a quasar, but by pure astronomical chance, the literal barrel of its plasma jet is aimed directly at planet Earth. If a blazar were located in our local stellar neighborhood, the beam would violently strip away Earth's atmosphere and boil our oceans in a matter of hours. Blazars are the brightest continuous light sources in reality, but in terms of sheer, brute physical size, they are still dwarfed by the ultimate heavyweights of the cosmos. Ultramassive black hole. A black hole so incomprehensibly massive it violently curves the very fabric of space into a funhouse mirror. The event horizon is a pitch-black circle that takes up your entire field of view, blotting out millions of background galaxies. Ton 618 is an ultramassive black hole weighing a staggering 66 billion times more than our sun. If you placed it in the absolute center of our solar system, its black edge wouldn't just swallow Earth or Pluto. It would extend outward for 400 billion miles, violently swallowing the distant Oort cloud and physically touching the edge of interstellar space. If light, the fastest thing in existence, tried to travel straight across the black void, it would take a full week to reach the other side. These gargantuan giants sit alone at the centers of ancient galactic clusters, But eventually, gravity violently pulls everything together, resulting in the most extreme physical collision permitted by physics. Binary supermassive black hole. Two gargantuan black spheres spiraling around each other at terrifying speeds, physically churning the empty space between them into a violent, swirling whirlpool of distorted light. When two supermassive black holes merge, they do not quietly combine. In the final fraction of a second before their black edges physically touch, they are whipping around each other at one-third of the speed of light. The sheer, brute physical impact of their collision releases more energy than all the shining stars in the observable universe combined. This energy radiates out as invisible gravitational waves, ripples that physically stretch and squeeze the very fabric of spacetime itself, bending the shapes of planets millions of light years away. This collision creates a single dominant void that will outlive all the stars. But what happens when the universe dies and only the black holes remain? The Hawking radiation-era black hole, a lone, pitch-black sphere floating entirely alone in a dark universe with zero stars, slowly emitting a faint, ghostly, microscopic haze of thermal heat until it violently explodes in a blinding flash of pure white light. The universe is 13.8 billion years old. That is a single blink of a human eye compared to the lifespan of a dying black hole. It will take a Google years, a number 1 followed by 100 zeros, for a supermassive black hole to boil away through Hawking radiation. In this dead, freezing era of reality, the black hole physically shrinks, particle by particle over trillions of eons. When it finally reaches microscopic size, it detonates with the physical force of a billion nuclear warheads, leaving behind absolute, unblemished nothingness.